So our next speaker is Richard Jackson. He's from IPM Consulting. He's a principal occupational hygienist and he has experience in the mining, quarrying, manufacturing industries and working as an occupational hygienist, doing air sampling, looking at suitable control measures and everything associated with that. Thank you, Richard.
One of the greatest things following a professor is I don't actually have to talk about data. If anyone knows what an occupational hygienist is, you know that we love our data. So my aim today is really talking about the practical things that you can do on site to manage silica exposure to your workers. Essentially what I'm going to be talking about is looking at the guidance material that's available through Safe Work Australia and just discussing those sort of things. So we'll start from there. So I think the main aim when you're actually on site with your workers and with people when you're actually doing the work is consulting with people within the industry and actually discussing what's available out there, what practical controls you have as well, and having a look at a few things that are available on site. So mapping with your, my slides just went out of order, so I'll start again. The main sort of things that we look at are, and what I'm going to concentrate on is silica content within some of the products that you'll deal with on site, the size and form of the product that you will be exposed to on site, whether it's airborne, whether it's settled dust, and what makes it hazardous when you're actually exposed to it. When we look at a lot of things, and this is the slide that the lady down the front will be wanting to have a look at, so you can answer question one. When we go on site and actually talk to our workers and talk to people on site, we need to get an understanding of what actual materials they have on site. And based on what we see is generally the percentage or the concentration of silica within the materials they're looking at will determine what the exposures will be. And if you look at some of those, so if we look at granite, shale, natural sandstone, after the composite stone of sort of greater than 90, we get an understanding of what exposures are potentially out there. So as part of an occupational hygienist going on site, we actually want to really get an understanding of what the workers are exposed to and what they're using. Once we start looking at that, then we want to get an understanding of what is actually airborne and what they are going to be breathing in. So when we do monitoring on site, which I'll get to in a little bit of time, we want to actually get an understanding. We are really concentrating on this respirable fraction when we're looking at silica exposure. So less than 10 microns of particle size, which is quite fine and a lot smaller than sort of human hair. And I think we'll have a couple of slides later on that actually look at the particle size. That's what we're actually going to be monitoring and looking at from a crystalline silica point of view. So those particles that can easily get into the lower, deeper parts of the lungs and will potentially stay there and actually cause those health effects that were previously talked about. Some of the industries that we go in, as Pam introduced me, I've worked across a lot of different industries, and most of the industries that we actually look at, and some of these industries such as mining, rock drilling, quarrying, have understood and been doing a lot of the work around exposure to crystalline silica, and certainly from my experience over the last 15 years, that's generally where we see a lot of work put into protecting people's exposure. However, we're starting to see a lot more people from manufacturing, cement, foundry work, those type of things, agricultural earthworks, actually wanting to check and see if their workers are exposed to silica. And based on the different products that they're actually getting in and determining what their actual silica exposure goes to. This is probably really where I want to get into the deep parts of it. So when we actually go on site, what does an occupational hygienist do and what do we want to do on sites? And what should you do as workers or managers on site to protect people's health? So essentially the first part of is, what is the hazard? So we had a really good, the professor, he presented what the hazard is. So we're looking at silica as the hazard on site and what that harm does or what harmful effects it has on the body. The next step is to see who within our site is actually potentially harmed by that product or has the potential to have health effects from that product. So when you're on site and you're doing your risk assessments around the site, you really need to investigate all the people on your site, from admin right through to the people at the coalface and actually working in the industry. Now, some of the effects and some of the people that are potentially at harm will be really easily to identify. So people that are working in crusher sheds, people that are working with the product, you'll be able to really see the effects, and you'll be able to see the dust actually in the air. Some of the other ones, which are people that might be in close proximity to those tasks, may be a little bit more challenging. So really need to understand what and who may be exposed on site. And that then translates into actually what you're doing. So some days you may have no exposure, other days you may have really high exposure. So actually getting an understanding of what is a normal day, what is a normal exposure on site as well. And then discussing around, what can be done to eliminate or bring that exposure down to as low as reasonably practicable. So some of the things you look at is, you want to prioritise, who you might do monitoring on or who you might control the risk to. So in assessing that risk, you may want to actually do some monitoring. So when we start looking at monitoring, we have a few things that we need to do. We want to actually get an average across the whole shift. So we want to get a normal shift. We actually want to see a regular normal type shift. We don't want to get the lowest, we don't want to walk on site and actually get a shift where someone's sitting in an office for 6 out of the 8 days. Or 6 out of the 8 hours that we're monitoring. We actually want to get their normal shift, normal tasks. We want to get a range of tasks as well. So, we get a whole understanding of what their tasks and what their work involves. We want to make sure that the actual monitor is attached into their breathing zone. So generally up on the collar. This gives us a relatively good understanding of what they're breathing in and an estimate. And it's an estimate. It's not exactly what they're breathing in, but it gives us an estimate of what their exposure is. And then we want to compare those results to the exposure standard. So when we're looking at a little sample train, generally the worker will wear a monitoring pump, connect to a tube, and then we've got the sample head at the top. So when we actually start looking at what the exposure standard is and what we can compare the results of this monitoring to, what are the exposure standards? What do they mean? So essentially, when we're measuring silica and the respirable dust in there and determining whether it's satisfactory or adequate, or whether it's I use the word safe very loosely. We get a range, but exposure standards are essentially based on airborne concentrations of the substance, so in this case silica, which based on all the knowledge that we have up until that point should not cause adverse health effects. So with all the information that we've had in the past, we come up with a number. So up until the end of last year, we had the current workplace exposure standard of 0.1 milligrams per cubic metre in the air. And that's based on an 8-hour working day, 5 days a week over a working life. Now, we've had a change in the workplace exposure standard. It's been dropped down to 0.05 milligrams per cubic metre, and a lot of regulatory bodies around Australia are actually starting to adopt that figure now. Currently, there's not a huge amount of talk coming out of Tasmania as far as where that sits. At the moment, there's a bit of conjecture as whether it's actually relevant or whether it is fully enforceable at the moment. My recommendation around workplace exposure standards is going as low as reasonably practical. We've got a number now which is 0.05 milligrams per cubic metre that would be, and certainly from my point of view, a recommendation to any of our clients to actually work towards and actually achieving to get it down to as low as reasonably practicable. Once again, you don't wait till you get to that number either. You don't want to wait till you get to 0.05 milligrams per cubic metre or the 0.1 milligrams per cubic metre before you actually start implementing your controls. As we say, it's a guide to when adverse health effects may be caused. It's not a fine. It's not a pass or fail. It's not at 0.1 you're going to get health effects. At less than that every day you're not going to get work or health effects. You want to make sure that you're actually managing the exposure over the period of time and not just as a one-off. So you want to get it down as low as possible. When we start looking at our controls, we want to start working with the hierarchy of control. So when you're actually doing your risk assessment and you're actually going through and you're looking at your workplace, you want to be thinking about what are the best controls that we can actually implement in this area and within our workplace. So most of you would have seen the hierarchy of control. Obviously you want to eliminate the risks if possible. So using products that are of a lower silica concentration if it's a possible outcome. It may be difficult in certain industries, so you want to actually start them working down to looking at substituting for different products. You may actually want to isolate or engineer out of the products. So I know there'll be a bit more information on engineering and sort of ventilation controls, but we start looking at a few other things around local exhaust ventilation, actually moving the dust away from the breathing zone of the worker, and actually having that in place. So as you can see, we want to move, this gentleman here, it's directly under there. We actually want to make sure that we're moving the particles away from their breathing zone. Wet cutting is another potential option for cutting things. And again, working with different types of controls. So it might not be one control is the best option. You might want to actually implement a few controls to minimise and to bring your workers' exposure down to as low as reasonably practicable. As I say, working through a risk assessment is the best way of doing this. So you want to actually get an understanding of what the risk is, who's exposed, where the controls are going to be best utilised. PPE controls, again, that'll be spoken about a bit more, but a few varying controls, just making sure that you do have a range of PPE available for workers and respiratory protection available for workers, depending on their exposure, depending on who's using them, making sure they're trained, fit tested, but again, we'll have another speaker shortly that will talk about those. Health surveillance, again, as part of your risk assessment, and if you do identify that there is potential risk associated with silica within your workplace, you want to make sure that you have your workers assessed. So if there is risk, make sure you have health surveillance prior to them starting work, and then regularly, continuously throughout that work period, so depending on their risk. And make sure it's done by a suitably qualified and trained doctor. You're wanting to make sure that the person that's actually doing the testing knows what they're actually looking at and actually providing the right information around that. They may look at a few different options around health surveillance, so things like lung function tests, x-rays may be required depending on the level of exposure. So what do we do from here? I think from my point of view, there's a few things you can do. If you are exposed, or if you know of people that are exposed on site, or if you have a feeling that your site is at risk of potentially exposing people to silica, there are a lot of things that we can do. So the immediate things that you can do is identify within your workplace if it is a dusty environment. As Pam said right up at the start, if people are breathing things in, if they're breathing dust in and at certain quantities and over a period of time, there is risk to their health. So the aim is to protect that worker's health. And if they're not breathing anything in, there's no risk. So if they're not breathing silica in, there's no risk to their health. So identifying what sort of controls you can do. So immediately you could actually implement fairly simple, fairly lower order controls to ensure that people aren't breathing the silica in and inhaling it into their lungs. So PPE, rotating their jobs so their exposure periods aren't as long, so lessening their exposure. Reducing the number of workers that aren't actually involved in that work as well. So if you've got bystanders around, only having designated areas set up for cutting cement sheet or cutting the bench tops. Medium term, risk assessing, monitoring, if you're unsure of exposure, actually doing the monitoring and actually assessing it. Making sure that it is a fairly thorough monitoring job. So do we rely on one little data set, or do we monitor over a period of time? Now, depending on, obviously, there's cost implications around doing a large monitoring program to understand your exposures. But if you are going to do monitoring, just making sure that you get the right data and have it correctly looked at. So, not having one data saying that you're under or lower than the exposure standard and relying on that. You want to make sure that you're actually assessing the right work. Longer term, then looking at sort of automation or elimination. So, automating the process, eliminating the hazard, and that can be planned into and budgeted for over a period of time. So, and that pretty much sums up what I do, but as an hygienist. So, thanks very much. I think I covered most of it.
We actually have some time for a couple of questions. Anybody with any questions at all?
Dust from dusty roads.
Dust from dusty roads. Yeah, good question. So it will depend on the type of, what's that making up the road. So as we've sort of said, depending on the concentration of silica within those roads, that'll be made up of a lot of different dust and a lot of different sized particles within that dust. So certainly there is potential for there to be silica and silica in particle sizes that are respirable. So there is potential hazards there, but it really depends on what it's made up of and how it's actually generated. Yep. So I can't, you might go to one road where it might be really high concentrations of silica, and you might go to another one where it'd be very low, depending on the actual product they've used and depending on how it's been generated. So, yep. But there is potential risk there, whether it's high risk or low risk. Yeah, it really depends on the site. And then you're also looking at exposure duration as well. So obviously if you're exposed over a period, if you're standing on that dusty road for 8 hours a day, 5 days a week for a while, then yeah, your risk will go up. If it's just a one-off exposure, then potentially your risk's a lot lower, depending on the concentration and the silica type.
Are you aware of a silica register similar to the asbestos register where people their names in this, they think they've been exposed?
I am not. I've heard talk, but not anything official. But potentially there is. As I say, I'm not over that. So, yeah. Yep.
When you say isolating the procedure as one of the controls, what would that require? Would that require physical barriers or distance?
Yep. Yeah. So a bit of both. So physical barriers, isolation type chambers, those type of things, depending on the process. So obviously the further away a person is from the production, then that's a good way of doing it as well. But so, yeah, any type of or any combination of distance, barriers, ventilation controls, those sort of things. So yeah. Again, it depends on the dust generation and what's actually generating it. But certainly I'd probably look at concentrating. If you're not part of the process, then you'd be moving that worker out of that area and just having a designated setup. If say if you're cutting cement sheet, for example, having a designated area that has the correct ventilation in there, correct controls, and rotating people through that sort of environment and having people that aren't part of that task removed from that area. Yep.
Yeah. If you're working in a built-up suburb, mm-hmm. And you've got a mask on yourself, you're cutting cement sheets or you're drilling holes in cement, mm-hmm. Is that deemed to be a safe practice, given that there might be kids playing next door? Or
did you see the ad?
Yeah. That was inside. I wondered what the official line is with capturing.
Again, it looks at
working outside.
Yeah, from my point of view, I always look at the practicality of it and the risk associated with doing something like that. My thoughts would be, I'm putting controls in place to protect me from breathing it in. And then, as we just said, around the isolation and moving people away from that area and having an area that's actually isolated to that task. Obviously, if dust is generated, it'll get less and less concentration as it dilutes the further and further it gets away. But yeah, again, it depends on the product. I'd like to say, it'd be a relatively low risk to someone playing 50, 100 metres away from that area. But if someone's within 2 or 3 metres and you're cutting it, then obviously the risk increases. But then you go to duration as well. So duration of exposure. Yeah, so if you're a workplace, you'd have, the first thing I'd be looking at having is an operating procedure and going through that and actually doing your risk assessment based on what you're the task is, and then from that you can introduce controls based on isolating the area or having distances between you and the next person that's doing their work.
I mean, we can control it on site.
Yep.
But I just wondered, given, if you're in a neighbourhood,
Yep.
you can sort of control it within the boundary fences of where you're working.
Yep.
My question to you is how far outside of your...
Depends how good if you've got particularly good controls that are suppressing the dust from that product, then, you could probably bring the area in a bit more, but it's task by task sort of assessment depending, on risk. So, and one person might do it really well and other people might just do it and let the dust naturally ventilate out of the open space. So, it's a really challenging one, but certainly I'd be working through the risk associated with doing that task prior to actually doing it and then coming up with the controls around that.
But you also have to look at where your ventilator's blowing the dust to.
Yeah, so all that's should be taken into consideration as well. Again, whether it leads, if we're looking at leading to disease, then you're looking at that. So my experience is looking at workplaces and controlling workplace exposure. There are other standards around environmental exposures that look at particle size rather than specific respirable crystalline silica or specifics around it. But certainly, part of your, I suppose, ethics and certainly management of the dust, you'd be looking at your potential exposure to other people in surrounding areas and environmental exposure. Yep.
I think we're going to... One more question and then we have to move on.
Who wants to go? Yep.
You mentioned controlling the dust using, say, a vacuum sort of filtration system or water suppression. Have you done a lot of assessment as to how well the filters in the vacuum work with something as small as 10 micrometers?
I'm not sure whether I can answer. Could that be something I reckon you might get the answers in the next presentation. Yeah. Yep.
Well, thank you, Richard.
Yeah.
Thank you.